Hello everyone. Today I am going to discuss the fifth problem of AtCoder beginner contest 347, which is set at query. So what is the problem? We are given an integer sequence A of n integers where all the elements are initially 0. So we are not given an integer sequence, but we have to assume that there is an integer sequence of length n with all zeros. Now also there is a set S which is initially empty. Now we have to perform the following q queries in order. So what are the queries? In each query we will be given some integer xi, and we have to perform some operation. Okay, and after all the queries are done, we have to print the what we have to print, uh, find the value of each element in the sequence A after processing all the q queries. So let's take one example, you will understand it better. So let's take this 341332. Okay, so what are the operations? So in the first, initially all there are three elements which all are 0. So initially there are three zeros. Now at the first operation we have what we have to do, and our set will be empty. Our set is empty. At the first operation we have to add 1 in the set. So we have to add 1 in the set. Now what we have to do, we have to take this integer 1 and add 1, the length of the set, to the specific index. So we have to add 1, length of the set is 1, so we have to add 1 here. So it will be 1 0 0 like that. Now again, the second operation we have to add 3 to the set, so it will be 1 3 like that. Now 1 3, so we have to add the length of the s2 to the index 1 and 3. So we'll have to add 2 here, so it will be 3, and have to add 2 here at the third index, so it will be 302. And at the third operation, there is also 3, but 3 is already in the set, so we have to remove the 3 from the set. And similarly you have to add length of the s to 1, so it will be 402. Now at the end we have to add 2 in the set, so it will become 1 comma 2. Now we have to add length of the s, which is 2, to all the elements, so it will be become 6, I think it will become 622. So our answer is 622. Okay, so I have explained one example. Now let's discuss about some observation. So the first observation is from our constants. So what is the constant? Constants on n and q is 2 into 10 to the power 5. So the possible time complexity could be order of n plus q, or order of n plus q log n, or you can say it is order of n log n. That's the first observation, that we have to solve the problem in n plus q or n plus q log n. Now what are the other observations? Now the brute force solution for this is that when we are adding some element, when we are doing some operation, iterate over all the indexes that are currently present in the set, and add the length of the set in the answer. Okay, so what we can do, when we are at some index 1, we have to add 1 to the first index. Similarly, when we are doing the second operation, we have to add 2 to first and third index. Similarly, so the total time complexity of the brute force algorithm, the brute force algorithm will be could be around order of n into q. Brute force solution order of n into q, which is definitely not possible. So it is not possible to do all the operations, right, while adding some element into the set, perform the addition. That is not possible, so we have to compute that lazily. So how we can add the element, add the length of the set lazily? So what I thought about is that when we are deleting some element from the set, so we will maintain one running sum. So the running sum will be the addition of the length of the sets after each operation. So initially the running sum is 0. After the first operation the running sum is 0 plus 1. After the second operation the running sum is 0 plus 1 plus 2, like that. We will maintain that. Okay, now when we are deleting some element from the set, when we are deleting this 3 from the set, what we will do, we will check what is the running sum when 3 was added. So the running sum when 3 was added is 1, and when what is the running sum when 3 is getting deleted? So when 3 is getting deleted, the running sum is 3. So what will we do, we will add 2 to the third index. We'll add 2 to the third index. That's my observation, or you can say approach, is that perform addition while deleting. So perform addition while deleting. Why this approach will help us? Because at a point, at any operation, we are only deleting one element, and adding something to the element is order of 1. So we are doing some order of 1 addition operation in some of the query operations when we are deleting something from the set. So after all the queries are done, there will be some elements left in the set, so we have to remove those elements, or you can say we have to delete those elements from the set also. That's the algorithm. I hope you get the algorithm what we are doing. We are maintaining one running sum, that the sum of the sets, and when we are deleting some element from the set, we are checking that when this element was added in the set, what was the sum, and after that when this element is getting added, all the sums like 1 plus 2 will be added to the specific index. So let's look at the code, you will understand it better. So here I am maintaining one dictionary D, so or map you can say. So D will maintain that what is the running sum when it was added. So D of 3 will be 1, because when 3 was added in the set, it was the sum was 1. Okay, D of 1 will be 0. Okay, similarly like that. So we are iterating over all the elements, all the xi elements. If I is in s, then we have to remove the element from the s, and similarly we have to add c minus dy. C means the current running sum, and di means the sum when the current element was added. So we have to add answer of I minus 1, because it is zero based indexing, answer of I plus equals to c minus di, and we are removing the element. Similarly, not similarly, when we are adding something in the set, we will be changing the di value to the current running sum, and we are adding that element into the set, and we are doing c plus equals to length of s. Okay, so I hope you get this problem, and at the end of the operations are done, we have to delete all the remaining elements from the set. So what we are doing, we are iterating over all the elements in the set and doing answer of I minus 1 plus equals to c minus d of I. Okay, so what is the time complexity? We are maintaining one set, and the addition or deletion from the set is log n. So overall time complexity is like order of q log n. Okay, uh, and the other deletion and addition operations are order of 1, so we are not considering that. So I hope you get this problem. The problem is quite nice, and I will also provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. Also, if you have any doubt in any part of the video explanation or code, you can always write in the comment section. I will try to reply each and every comment. Please like the video and subscribe to my channel. Thank you.